Good evening, my dear JEE warriors. Welcome to the next session, your remaining part of your JEE Mains PYQs of current, electricity and capacitors. Last lecture, we have done the April attempt questions. Today, we'll do the January attempt questions from the chapter of current, electricity and capacitors. One of the highest weightage chapters in your JEE Mains. You will see so many questions and so many repeated models, right? Every year, every single shift. Good evening, Gauri. Thank you for all the love from Tamil Nadu, my birth state. Hello, Harbourine. Ready, says Captain. Okay, amazing. Bhavani, Virat. How many questions? I think there are around 35 or 34 questions. I'm not really sure, but more than 30 questions are there from the January shift from these two chapters alone, which is in itself a very good number. So first of all, like the video, because only when I see those likes, I know that you are attending. Number one. Number two, you are supporting. Number three, if you want more sessions, like it. Else, I have no reason or incentive to conduct more sessions. Guys, I'm not asking you for money. I'm asking you for like. It's a free of thing, cost thing, right? And subscribe to the channel or else you will miss any other class which we are conducting over here. This is a proper academic channel without any nonsense. To the point, we give you proper content so that you will excel in your JEE. We don't fool you by telling you unrealistic things. We do not tell you things which are not achievable. We will make sure we will conquer JEE Mains 2024 and after that JEE Advanced 2024. Sorry, 2025, my bad. Yeah. So make sure you are up to the speed, you are following all the classes, you are very regular and show your sincerity, right? By attending either live or even recorded. That's fine. And leave a comment that shows that you are very sincere, committed towards your goal. Starting off with the first question coming up on your screen, and we are doing around 25 questions in current electricity. Here is the first one. There's a meter bridge with some resistance in the left gap, unknown resistance in the right gap. The balancing length is 40. On shunting it with the unknown shunting the unknown resistance with 2 ohm, the balancing length changes by how many centimeters? That's the question. In the first situation, think of it this way. When the resistance in the left gap is 2 ohm, so this is 2 ohm, and there is an unknown resistance X in the right side gap, and you tell me that the balancing length is 40 centimeters. So this length over here will be 60 centimeters, right? This is what it means. So 2 divided by X, resistance 1 by resistance 2 will be this length by this length, which is 40 divided by 60. 40 divided by 60 is 2 by 3. Hence, I will see that the value of X is nothing but 3 ohm. That is the unknown resistance which is kept in the right gap. This unknown resistance which is kept in the right gap. Now, when you shunt the unknown resistance with some resistance of 2 ohms, okay. So, imagine this 2 ohm is as it is. You are shunting this 3 ohm with another resistance. Shunting means keeping it in parallel. How much parallel resistance? 2 ohms. What do you think will the balancing length shift by? Well, one thing is obvious, that it will have a new balancing length over here, something like this. Okay, so if this is L, this will be nothing but 100 centimeters minus L. Now, this will behave like one equivalent resistance in parallel. This is another resistance together with it. So resistance 1 divided by this resistance. How much is this resistance in parallel going to behave like? These two together will be nothing but R1 R2 divided by R1 plus R2, which means it is 6 by 5. So here I'll put this resistance by this whole resistance, which is nothing but 6 by 5, is equal to this length by this length, which means it is L divided by 100 minus L. 2 goes with 6 3 times, 5 goes on the top, so 5 by 3 is equal to L by 100 minus L. Cross multiply, so you will get 500 minus 5L is equal to 3L. So basically 500 is equal to 8 times of L. So therefore, what you will get is nothing but L is nothing but 500 divided by 8 divided with 4 or divided by 2, 250. This will become 4. So this will become 125 by 2, which is nothing but 62.5. So the balancing length has now become, the new balancing length has become 62.5. Earlier it was 40, so it has changed by how much? It has changed by 22.5. Lot of people marked 62.5 in the answer. That is not the correct answer. The question was how much did it change by? So it is 62.5 minus 40, which is 22.5 centimeters. Is that right? So chances of silly mistake in this question are very high. Imagine the pain in the student's mind and heart if that student found out 62.5 and marked this. Imagine solving all of this and just missing those 4 marks and getting a negative mark because of this silly mistake. It will pain a lot. So that's why let your hard work not go in vain. Let it not be useless. So make sure you are reading everything properly and giving the answer as per the question, not what you got. Question asks you change, not something which is final. In an ammeter, 5% of the main current passes through the galvanometer. The resistance of the galvanometer is G. The resistance of the ammeter will be how much? Okay, let's see. Hello, Wali Surat. Good evening. Hello, Sham. Welcome, welcome, welcome. Yes, Nandu, always my guidance will be there for all of you. Grade 11th, laws of motion will be coming very soon, maybe by Saturday, hopefully. Let's see. Okay, let's solve this question, my dear students. It's clearly mentioned 5% of the current passes through the galvanometer. So this is the galvanometer. The remaining 95% passes through basically the shunt resistance. So the question is the resistance of the ammeter is how much? See, 5% is passing, meaning imagine the current was 100I. So the current passing here is 5I and the remaining current over here is basically 95I. Since the shunt and the galvanometer both are in parallel, the voltage drop being the same, that's why I can say, because the voltage drop is the same in parallel, I can say voltage, which is I into R, so 95I, which is the current into the shunt resistance, is equal to nothing but this I, which is nothing but 5I into G. Perfect. So I cancels, 5 goes with 95 19 times, 95 RS is equal to G. So 19 times the shunt resistance is basically the galvanometer resistance. Once I get this, easily we can figure out what is the total resistance of the ammeter. Now ask the resistance of the ammeter. Okay, be careful. So what will I do? Yes, I will find out the parallel resistance. Parallel resistance is R1 R2 by R1 plus R2. So it is RS into G upon RS plus G. So what is RS or G? Let's say for example G will substitute. So G is nothing but 19 times of RS, the whole thing divided by RS plus G. So RS plus 19 RS right over here. So this RS will cancel. So 1 RS I will take it outside, 19 will remain here, and 1 plus 19 is basically 20. So basically it is 19 by 20 times of RS, but I want the answer in terms of G. So RS is G by 19. RS is basically G divided by 19. So into 19 divided by 20, 19 cancels. So it will just become G by 20. So G by 20 is basically option number C. I just substituted RS as G by 19 right from here. You can see it right over here that RS is G by 19, which I have substituted it over here. Cool, everyone? Awesome. See if you got it till this point, and if you're loving the questions, keep smashing the like button. Do not hesitate. Do not hold yourself back from liking the video. Moving on, next question on your screen. The reading in the voltmeter in the following circuit is how much? Okay, you can see batteries one after the other with internal resistance, voltage between any 2 points. Guys, every time these kind of questions come, I'll tell you what happens. See, whenever there is a battery internal resistance like that, no matter how many such batteries you keep, and if you are ending up measuring the voltage across any one such battery, what you should do is, first of all, find the current in the circuit. What is the current in the circuit? The current in the circuit is the total voltage upon the total resistance. Total voltage will be N times of E. total resistance will be N times of R. So it will be basically E by R. R, all are in series, all the batteries are helping each other. So the voltages will add, resistances will also add. In order to measure this voltage, this voltmeter reading is basically the terminal voltage across a cell. The terminal voltage across a cell. And terminal voltage is basically E minus IR. But I is nothing but E by R. And this R is as it is. RR cancels. So it will just become E minus E, which is basically 0 volt. So no matter how many batteries, what the voltage is, always the answer will be 0 volts in such questions. Okay, always the answer is 0 volts. You will see. So it doesn't matter what the voltage, what the resistance, or how many are there. Yeah, I think we had solved this question maybe in the previous lecture, maybe somewhere, but yeah, that's the answer for this. So I've given a general, oh my god, why did I show you the answer of this question? Already I showed you the answer. I think the question slide was missing for some reason. Anyways, I'll just solve the question now that you know the answer. Galvanometer has some resistance, maximum current converted into a voltmeter. So what should be the series resistance? See guys, the galvanometer, the resistance is given, maximum current is given. So to convert it into a voltmeter, I need to connect a resistor in series. I need to connect a resistor in series so that it behaves like a voltmeter. And the voltage drop across these 2 points is going to be now 100 volts. And as mentioned in question, the maximum current which can flow through this is 5 milliamperes. That means 5 into 10 to the power minus 3 amperes. Resistance of the galvanometer already given. How much is it? 50 ohms. Guys, both these resistors are in series. So the equivalent resistance will be this plus this. So this total resistance allows this much current for a voltage drop of 100. So simply use voltage is equal to current into equivalent resistance. The voltage is 100. Current is 5 into 10 to the power minus 3. Resistance is 50 plus S. They are in series, so equivalent will be the addition of both of them. So take this 10 to the power 3 on the other side, it will become 10 to the power 5, or you can just do one thing, 10 to the power 4 into 10, this 5 you bring it down over here, and this will be 50 plus basically S. So 5 goes with 10 2 times, so you have 1, 2, 3, 4 zeros is equal to 50 plus S. Therefore, our S will be 20,000 minus 50, which is 19,950 ohms, which is option number D. Got it? I have always been telling all my students that whenever you get voltmeter and ammeter questions, don't by heart or recollect any formulas. In fact, recollect how the setup is, whether shunt is there, series resistance is there, and just treat it like your normal series or parallel resistance problem. Use your basic Kirchhoff's laws or Ohm's laws, whatever basic laws are there. If you notice, that's exactly what I've done. I did not recollect any formula. I just know Ohm's law. I know if it is a voltmeter, I need to connect a resistor in series. The total voltage across both these collective resistors should be 100. And you solve it like a normal Ohm's law or resistor combination problem. Is that right? Shunt means, Karthik, parallel. Anything which is in parallel is called as shunt. That's a alternative name. Like in your home, maybe you might be called Chintu, Bantu, whatever. So it's just a alternative name for parallel. Okay. By what percentage will the illumination of the lamp decrease if the current drops by 20%? This is also asked in JEE Mains 2024, guys, in the January attempt. So what do we do in this particular question? Think. See, illumination, the illumination basically depends on the power loss, on the power which is basically lost across the resistance, and the power lost is nothing but I squared R. Oh, that means the illumination is directly proportional to the square of the current. So if the original illumination was L, okay, and the new illumination is L1, the old current will be I, the new current will be I1, and I will just square this. I'll just square this because illumination is directly proportional to the square of the current. Resistance will be the same. If the illumination drops by 20%. What does this mean? If it drops by 20%, which means if the old illumination was L, the drop is 20%, 20% of L. 20% is basically 0.2 L. Hence, the new illumination will be 0.8 L. So, L1 is basically, instead of L1, what you can put is nothing but 0.8 times of L. Is that right, everyone? Oh, sorry guys, the current has dropped, not the illumination. I'm so sorry. Not the illumination. The current has dropped. So sorry, not the illumination. So I will say if the old current was I, then the drop is 20% of I. 20% of I is basically 0.2 I. Hence the new current will be 0.8 I. I minus 0.2 is 0.8. So this I1 that you see over here, is basically 0.8 times of I. I will cancel, of course, and what will be left over here is nothing but 1 divided by 0.8 square, which is nothing but 1 divided by 0.64. So that is L by L1. So shifting, it will become 0.64 times of L. That means the new illumination is nothing but 0.64 times the old one. 0.64 times the old one. That means how much is the drop? That means the drop is basically 0.36. So 0.36, if you convert it into percentage, it will be basically 36%. So the drop will be 36%, which is B for IIT Bombay. Is that right, everyone? Yep. Do not use voltage into current because, over here, the question is about current being dropped. Number one. Number two, you do not know whether the, voltage will remain same or not. But I'm 100% sure resistance of a bulb will not change. So that is why better to use I squared R, because voltage may change because the current has changed. So do not use voltage into current. Is that okay? Shangila, is that 4 months enough to complete JEE Mains revision? I mean, if you're talking about revision, Shangila, I'm pretty sure it is good enough, because some people complete the syllabus of 12th standard and somewhat backlogs of 11th in 4 months. So if people can complete syllabus and get a decent percentile, 100%, you can cover the revision part in 4 months. Okay, you have good amount of time, but at least do 2 revisions since you have 4 months if you have gone into the revision phase. The resistance per centimeter of a meter bridge is R, and X resistance is in the left gap. Balancing length is 40 with 25 in the right gap. Now the wire is replaced with another wire of another resistance per centimeter. The new balancing length will be, see, there is some X resistance here, left gap, and 25 ohm here in the right gap, and it is mentioned that you get some balancing length. Which is 40 centimeter, and this is 60 centimeter. Now, if you change the resistance per unit length to something else, from R, you make it something else, this ratio won't change. How will resistance per unit length matter? It doesn't matter, because at the end of the day, X by 25 will still be 40 by 60. Nowhere in this equation you use resistance per unit length. So this has no effect. In the solution of the problem. So even the balancing length won't change. Hence the answer will still remain 40 centimeters. This was just a trick question. Unnecessary data given, a big paragraph is given, and then you feel that it's complicated and you might scratch your head thinking, what will change? How will this affect anything? The answer is it won't affect anything. So NTA or even JEE or even IIT is known to give such questions very often where nothing changes or nothing happens. The ratio is 1:1 or the answer is 0. It's quite common. So don't get baffled, don't get shocked. Have I done something wrong? If you're clear with your concepts, you will definitely get the correct answer. Okay, cool. Let's go with the next question coming up on your screen. Two conductors different coefficients of thermal resistance if they are in series versus parallel, what do you think the respective equivalent will be? Okay, so I'll create duplicate. I will need one for series, one for parallel. See, if the resistors are in series, if the resistors basically are two conductors have the same resistance, this is R, this is also R, but their coefficients are different. This is alpha 1, this is alpha 2. I will rewrite it as one single resistance RS, which will now be basically 2R, but it will have, if think about it guys, if I convert these two resistances into one single resistance, the one single resistance will have base resistance of 2R and equivalent thermal coefficient of, let's say, alpha S. So why did I write it as 2R? This 2R is at 0 degrees Celsius, but at some temperature it will not be 2R, it will be something else. What will it be? It will be basically 2R into 1 plus alpha S delta T. 1 plus alpha S delta T. What about these two resistances at some temperature? It will be R into 1 plus alpha 1 delta T. This will be also R into 1 plus alpha 2 delta T. And since they are in series, I will add them to get this equivalent resistance. Is this equation clear? These resistances are the base resistances at 0 Celsius. At some temperature, the new resistances will be adding to give you the new equivalent resistance. This stands for the equivalent thermal coefficient. Now, what do you do? RRR will cancel, of course, you can see that very clearly. So, 1 plus alpha 1 delta T plus 1 plus alpha 2 delta T. In fact, delta T also cancels. No, not yet. Alpha 2 delta T is equal to, here I have basically the number 2. I have the number 2 plus 2 alpha S delta T. I think now I can start cancelling few things here and there. This 2 will cancel with this 1 and this 1. 1 plus 1 is 2. RHS, LHS has that. Delta T will cancel. So essentially, what am I left with is nothing but alpha S is alpha 1 plus alpha 2. Alpha S is basically alpha 1 plus alpha 2. Just check this out, but it is 2 times. So therefore, alpha S is nothing but alpha 1 plus alpha 2 by 2. Alpha 1 plus alpha 2 by 2. So I can see B and D options have it. So C option can't be correct, nor can A option be correct. Till this part, everything clear? My dear students? How we did it for series? Very good. Awesome. Great. Now what do you do, my warriors? Just tell me. For parallel will be the tricky one. Parallel is not going to be so easy. It's going to be little bit tricky. What will we do? Yes, think about it. We will redraw the circuit now. Again, let's say this is R. This is also R, like this. This is R. This is alpha 1. This is alpha 2. If you convert it into a parallel circuit, what do you think this base resistance will be? What should I write over there? Quickly think and tell me. What would the base resistance be? Quickly think and tell me what would the base resistance be. It won't be 2R for sure. It won't be R for sure. It will be R by 2. Yes, the base resistance will be R by 2 and the equivalent coefficient will be alpha P. And we know how resistances add up in parallel. It is the reciprocals which add. So 1 by resistance for this one will be R into 1 plus alpha 1 delta T plus 1 by R into 1 plus alpha 2 delta T. This is the equivalent resistance at some temperature will be equal to, this resistance at some temperature will be 1 by R by 2 1 plus alpha P delta T. Fair enough. Now what we do is basically this R and this R just gets cancelled. I think I need to take the LCM right over here. So the LCM of this will be 1 plus alpha 1 delta T into 1 plus alpha 2 delta T. Here I will get 1 plus alpha 2 delta T plus 1 plus alpha 1 delta t is equal to, you will see the number 2 will go on the top, and we will be left with 1 plus alpha p delta t. Okay, fair enough. Now let's do the simple math over here. What do we get? 1 plus 1 is 2 plus alpha 1 plus alpha 2, the whole thing into delta t, whole thing divided by, observe this, 1 into 1, 1 plus 1 into alpha 2 delta t is alpha 2 delta t. Alpha 1 delta t into 1 is just alpha 1 delta t, and these numbers again multiply. So alpha 1 alpha 2 delta t square is equal to the same thing. Now the funny part is that not all the things will be accountable, because some of the things will be very small. Like usually alpha values, they are 10 to the power minus 4, minus 5. They are very, very small. They are very, very small, isn't it? They are extremely small. So what can we do? What can we do? We can just neglect those terms in front of the bigger terms. So I think it is good for me to neglect this. It is good for me to neglect this, because 10 to the power minus 5 into 10 to the power minus 5 will become very, very small, number one. In fact, even this will become very negligible, because 2 is a huge number. This is 10 to the power minus 5, 6, like that. It's very, very small. So I say that let's just forget about it. And then on the right hand side, we still have this number 2 divided by 1 plus alpha p delta t. I have a feeling few more things might get cancelled. Once this is gone, even this number 2 over here and this number 2 will get cancelled. Perfect. So now let's write everything in the denominator on the top, this number on the top. So I'll have 1 plus, I can take alpha 1 plus alpha 2 common, and this is delta t is equal to 1 plus alpha p delta t right over here. Just check this out. Yes, kind of makes sense. 1, 1 cancels. What do you get alpha p as? What do you get alpha p as? Just check this out. What do you get alpha p as? Yep. Come on, my dear warriors. Yes, we are getting it as D. Very good. Awesome. 1, 1 cancels. So alpha p will be nothing but alpha 1 plus basically alpha 2. So alpha 1 plus alpha 2 is right over here, and this thing is right over here. So we eliminated already C and Q option. Okay, so that's how you do these particular questions. Awesome. Teresa Matthew, I am in 12th. I am so scared for the exam. Only 4 months. My physics is weak. If you keep thinking, if you keep getting scared, trust me, nothing will improve. Stop watching reels. Stop getting scared by negative people. Stop all the distractions. Just focus on academic content and pure channels which, do not scare you, which instill confidence. Start by 0. Don't start by number 9 or number 10. Start with 0. Go to 1, 2, 3, 4 sequentially. As much as you can do it. Some things you will learn, some things you will do well in January attempt. Whatever you don't do well, you have April attempt. But don't give up on your January attempt so easily. You have 4 months, you can do a lot. I've seen many students do extremely well in their JEE, even in 4 months. When a potential is applied across a resistor, it dissipates some energy at the rate W. If the wire is cut into 2 halves and these halves are connected across parallel with the same supply, the new energy will be how much? Not that difficult at all. See, you have a wire of basically some resistance R, and if it is connected across this voltage, the power is V. The power is given by V square by R. Now what you do is basically break this resistor into 2 parts, and you are connecting it in parallel, something like this. So that behaves like an equivalent resistance of R by, sorry, not even R by 2, my bad. Each one will be R by 2, this will be also R by 2. So the equivalent resistance will be basically R by 4 ohms. Do you understand why R by 4? Because they are now in parallel and they are connected across the same voltage. So what should be the new power? Think about it. The new power should be V square by R by 4. That means it is 4 times V square by R. That means it is 4 times the old power. 4 times the old power, which is B for IIT Bombay. Which is B for IIT Bombay. Got it, everyone? Is it absolutely clear, everyone? Is it absolutely clear? Awesome. Great. Let's move on to the next question on your screen. A potential divider circuit is shown. The output voltage V0 is how much? Amazing. Let's have a look. Let's have a look. 4 volts, 3.3, which is 3300. 1, 2, 3, 4, 5, 6, 7. So this is 700 ohms. So technically speaking, this 4 volt is connected to 3300 plus this 700 ohms. So that means the current in the circuit will be voltage divided by the resistance, which is 4000 ohms. 4 volts divided by 4000. 4 cancels, so it will become 1 milliamperes, which is 10 to the power minus 3 amperes. So that is the amount of current which will flow. If you want to measure this particular voltage V0, and I know this current is 10 to the power minus 3, how many resistances are there? 1, 2, 3, 4, 5. So 500 ohms is there right from here till here. So the voltage V0 will be current into resistance. Current is 10 to the power minus 3, resistance is 500, so it will just be 0.5 volts, I believe. 0.5 volts is C for Captain Shreyas. Very good, Captain Shreyas is the answer. Everyone with me? Very good, awesome, awesome. Let's move to the next question. These kind of questions do come, guys. Yeah, moving on. Next one on your screen. There is a toaster which has some resistance at some room temperature. Now it is connected to the supply. Now if the current reaches 2.75 amperes, the temperature attained by the toaster is around. Okay, I know the base resistance at 27 degrees Celsius. If I can find out the new resistance at some increased temperature, then I think I will be able to find, the whatever, thermal coefficient, the temperature which is attained. Thermal coefficient is already mentioned. See, I know the voltage and I also know the current, which means that the new resistance at temperature T, V is equal to IR, so R is equal to voltage by current. So voltage is 220, current is basically 2.75. But we already know resistance at temperature T is R0, 1 plus alpha delta T. This is nothing but 220 divided by 2.75. This is nothing but 60. 1 plus alpha. What is alpha? 2 into 10 to the power minus 4 into delta T. So what do you put delta T as? Basically final minus initial temperature. So final temperature is what we need to find. Initial is 27. That's it. In this equation solving, you will get the answer. The final answer comes out to be 1694 after solving. Okay. So this will come out to be 1694 degrees Celsius after solving it. But I hope you understood how to get it. What is the approach? What is the concept? Which formulas you have to apply? Shall we go ahead to the next one? Yes. Sir, can we connect to you via Insta, Lionel? Maybe yes, why not? Definitely. Yep. Okay. In the given circuit, what is the resistance R3? What is the resistance R3 current? Okay, let's figure it out. I can see this is 4, this is 4. So the equivalent of these two will be 2 ohms, 4 by 2. 2, 2 and 1 equivalent resistance will be 5 ohms. How did I get it? 2 plus 2 plus 1, which is 5 ohms. And it is connected across 10 volt. So that means what should be current in the circuit? What should be the current in the circuit? Voltage by resistance, which means 2 amperes. Now once this 2 amperes reaches here, it has two options, once here, once here. So 1 ampere will go here and the remaining 1 ampere will go here because the resistances are equal. So the current should be 1 ampere. Very straightforward. Okay, such simple questions also come. Moving on to the next one. The deflection of a galvanometer from 25 divisions falls to 5 divisions when you connect a shunt of 24 ohms. The resistance of the galvanometer coil. Wow, let's see. How do we solve this particular question? So, because of the shunt, the divisions, the deflection divisions falls from 25 to 5. Okay. So let's assume like this. Originally, let's say the current flowing in the galvanometer was 25I. Later on, the current flowing in it is basically 5I. So think of it this way, as if, originally 25I of current was trying to flow through the galvanometer, but because you have connected a shunt, over here, only 5I amount of current goes through it. That means the remaining current, which will be how much? 20I will go through the shunt resistance. And it will come back over here and it will collect and it will again come out over this side. This is the explanation of this statement. If you are able to visualize this, solving this will be easy, else you will be stuck with many formulas. Because there is no such formula for divisions. You have to think what is exactly happening. Now, the question is, what is the resistance of the galvanometer when a shunt is 24 ohms? So the shunt is already given to us, which is 24 ohms. And we know that both of them are basically in parallel. So voltage is same. So voltage is IR and it is same in parallel circuits. So therefore, for the shunt, the current into resistance will be 20I into, 24. For the galvanometer, it will be 5I into G. II cancels. So I will cancel, 5 and 20 will cancel, it will become 4. 4 into 24 is equal to G. So G is basically 96 ohms. 96 is C for Captain Shreyas. Yes, perfect. So we get it. Is that amazing, guys? Loved it? Very good, very good. So, I used a simple concept that, okay, 25 divisions means each division will be some current. Let's say I. So 25 divisions means 25I. What is I? Some multiplying factor. I know that this I will anyways get cancelled, maybe some way or the other. So no harm in assuming it. So if original current was 25I, when you connect the shunt, only 5I current is passing through it. That means the remaining current will be 20I going through the shunt. That's the logic behind this question. Moving on, galvanometer having a coil resistance of this shows a full scale deflection of 3. To measure 8 amperes, the value of the shunt should be. Again, so many questions on just ammeter, guys. So what do we do? First of all, I will show the galvanometer. I will also show the shunt over here. Okay. And I will say that 8 ampere of current is entering in, but this galvanometer having 10 ohm resistance has a full scale deflection current of 3 milliamperes. That means the remaining current will be 8 minus 3. Now don't think it is 5, this is ampere, this is milliampere. This is so small that taking away 3 milliamperes from 8 amperes will not change much. So this will still be approximately 8 ampere through the shunt resistance. Now again use the concept that since they are in parallel, the voltage which is IR is basically going to be the same in a parallel circuit. So you can directly say I into R, which is 8 multiplied by RS, will be I into R, which is 3 into 10 to the power minus 3 into 10. From this, you will get the value of RS. Just check it out if you are getting it as 3.75 into 10 to the power 3 minus 3. Yes, so I think it should be basically 30 divided by 8 into 10 to the power minus 3. 30 divided by 8 is 3.75, 10 to the power minus 3 ohms. Perfect. There you go. Okay. Again and again you are seeing the same thing. Just treat ammeter and voltmeter problems like a simple series and parallel circuit. Just that you should know whose voltage you are measuring, how are they connected, when are they in series, when are they in parallel, etc. Next question, shall we go ahead? All right, let's go. An electric current through a wire varies with time as follows. I naught and beta are given. Amount of charge through the wire is, okay, I think direct question. The total charge is always integral of current into dt. So over here from 0 to t. So over here the current is I naught is 20 plus beta is 3 into time, the whole thing into dt, and limits of the integration 20 seconds. So 0 to 20 seconds. That's it. It's just a simple integration. So 20 integration dt from 0 to 20 plus 3 into t's integration with respect to time from 0 to 20. That's it, guys. So this will be 20 into 20 minus 0 plus 3 into t square by 2. So it will be 20 square minus 0 square. Do the math and see if it is 1000 coulomb of charge. See if it is coming out to be 1000 coulomb of charge. Okay, that's the answer. It's very simple. Simple integration, nothing else is there in this. This was asked in the January attempt. Next question. 3 voltmeters are there and they are having different internal resistances and they are joined as shown in the figure. Same voltage is applied AB across this combination. What do you think is the correct relationship between them? This was just a trick question, I would say, and they are given some things just to confuse the students. Otherwise, there is nothing great about this question. I mean, there is nothing to solve also in this question, if you think. I mean, see this voltmeter V1, what will it do? It will show a reading of V1 volts across this point and this point. This voltmeter will show voltage V2 across this point and this point. So between A and B, the voltage difference will be V1 plus V2. So voltage difference between A and B will be V1 plus V2. What will V3 do? It will show the voltage difference between these 2 points. It will be V3, which is the same thing. They are, remember, in parallel. So in parallel, the voltage is across this and this will be the same. So there is nothing great. It's just option number C, guys. It's that simple. I mean, there was nothing in this, honestly. Chumma, it is given to confuse you. Okay, moving on to the next one. And as you are loving these questions, make sure you are subscribing to the Vedantu JEE English channel. Yeah, for your captain. Also, number 2, make sure you are liking the video, because only when you like, remember, you are motivating me to conduct more of these classes. We have already done so many of the PYQ classes in all the 3 subjects, physics, chemistry and maths. So make sure that you are liking, supporting the number 1 JEE English channel and the only JEE English channel in the country who has been consistent for the last 4 years, guys. Thank you so much. If you have not done that yet, please do that right now. This current of 200 microamperes deflects the moving coil galvanometer through 60 degrees. Current through deflected by pi by 10 radian is how much? Okay. So I feel first let's convert the 60 degrees into radian, which is pi by 3 radian. That is the first step, I believe. And current and deflection, what's the relationship between them? I know current is directly proportional to the deflection. So the new current by the old current will be the new deflection by the old deflection. Question is, what is the new current to cause that deflection? Okay, so old current was 200 microamperes. New deflection is pi by 10. Old deflection is pi by 3. Pi cancels, 3 goes on the top, 10 comes below. Is that right? And this is I2 by 200. Okay, so therefore I2 will be 0 cancels, 20 multiplied by 3, which is basically 60 microamperes. 60, which is D for ideally. Yes, perfectly there. Nothing but this. This is always true for any galvanometer. The current in it is proportional to the deflection, or the deflection in it is proportional to the current. One and the same thing. Yeah, you should know that. Can we entirely depend on you for the boards and JEE, sir? Please reply to me. Lionel, I'll tell you, for boards, no, on my NEET channel, there is a NEET English channel, again, that is there for all the students. Some of you might not know. I am taking care of NCERT line by line series because that is more relevant to NEET. So you can watch those sessions for your boards. That will definitely help you from especially boards perspective. Okay, only NCERT line by line for boards, and whatever I am doing here for JEE, that will be helpful for your JEE anyways. Okay, this will be for JEE mains and advanced, everything, right? Cool. Shall we go ahead? I hope I have answered your question also. All right, so okay, next question guys, coming up on your screen. Wheatstone is used to measure specific resistance, length L, radius R. X is the wire resistance, specific resistance is blah blah blah. Specific resistance means resistance of 1 meter length of cross section 1 meter square. Basically something like resistivity. If you think about it, R is equal to rho L by A. If you shift the terms, R into A divided by L, right? This, compare it with this, X is like resistance, pi R square is like area, L is like length. So rho is like resistivity. Okay, fair enough. If the length of the wire is doubled, the value of the specific resistance will be, wait a minute, this resistivity only depends on the, what does it depend on? It only depends on the material and the temperature, nothing else. It is not dependent on the length or area. So guys, this is a trick question, chumma given to confuse you. The answer will still remain the same. That means it will be D. It will remain the same. It is independent. It is independent of length or basically area. Length or basically area. It is dependent only on the material and the temperature. So answer will be the same. So like I said before also, trick questions expected. Not just one or maybe two. In fact, you can expect 3-4 trick questions where nothing is happening, 1:1 ratio, 0 volts, 0 force, something special is happening, none of this is there or all of this is there. So all these special type of questions expect in JEE mains. That is the one which is going to suck away your marks in the examination. That might give you negative marks in the examination. You might think something is wrong. You might waste more time. It will kill your time in the exam. Remember, maths will need a lot of time for you to solve in the exam. Chemistry will be the least. Physics will be medium. Oh, sorry, I showed the answer. But anyways, what is the question? The wire of certain length and radius is connected across the right gap. When a resistance is connected on the left gap, the balancing length is 60. The resistivity of the wire is how much? Okay, fair enough. Resistance of how much? 4.5 ohms. This is 4.5 ohms using the resistance box. It's chumma to confuse you. Resistance box or rheostat, whatever word they use. They say a resistance of 4.5 ohm is connected on the left gap by using a dinosaur. How does it matter? It's one and the same thing. Okay. Then over here you have another resistance in the right gap. So I will call it R, and there is some balancing length. Balancing length is 60 centimeters. Naturally, it's a meter bridge. The remaining length will be 40 centimeters. Divide the ratio of the resistances. So 4.5 by R will be basically 60 by 40. What is the question? The resistivity of the wire. Okay, so basically 0, 0 cancels. This will become 3 by 2. This is 4.5 divided by R. So naturally R will be 2 into 4.5 and divided by 3. 4.5 into 2, 9. 9 by 3 is 3. So 3 ohms. So resistance is 3 ohms, but that's not the end story. The end story is the resistivity, and we know resistance is the resistivity into length by area. So 3 is equal to rho. Rho I do not know. I have to find it out. Length I know is 0.1 meter. Area is pi, which is, area is basically pi r square. Pi is nothing but 22 by 7. Deliberately they are given root 7. You can figure that out why they are given. When you square root 7, it will just become 7, and this will become 10 to the power minus 8. Is that right? Everyone got it? Yes. Now you just need to solve it. 7, 7 cancels. 22 goes with 3. Oh, I use the power of 10 method. So rho will be 22 into 3 into power of 10. Something doesn't matter. 22 into 3 is basically 66 into some power of 10. I don't care about the power. I just know the number, numeric value will be 66. So I'll just mark C option. Don't waste your time in the exam calculating the decimal points and the powers of 10 and matching it here, because they are not interested in the power of 10. They are only interested in the numeric value, which is a power of 10. Yes. Sir, which materials are best? Ariant, what do you say? Handbook? You mean? Notes. Okay, I think maybe it's better that we connect on Insta or Telegram. That will be better. Instagram, Captain Shreyas. That's my handle. Telegram, Captain Shreyas. Everywhere you will find me by the name Captain Shreyas. Twitter, Captain Shreyas. Okay, everywhere. Right. So moving on. Next, there is a wire of certain resistance length L cut into 5 equal parts. These parts are joined parallelly. What is the new resistance? Guys, I want you to solve this and tell me the answer. This is very, very, very simple, but tricky also. You might make a silly mistake. So the old resistance is R. You divide it into 5 parts. Each part will be R by 5, R by 5, R by 5, R by 5, R by 5. Now you take these resistances and connect it in parallel. So R by 5 each. So what will be the equivalent resistance? R by 5, the whole thing divided by 5, which is R by 25. Is it there? Yes, option A. Option A is there. Perfect. Awesome, awesome, awesome. Very good. And why don't you leave a comment after the video ends? Maybe I'll answer that. That will be better. Cool. Let's go ahead to the next question. Very good. Some of you answered it. Very good, Anjana. Very good, Kishore. Very good, Harborine. Proud of all of you. Proud of all of you. Good evening, Anime God. Looks like you're a little bit late. Lionel, no worries, my dear student. You're not irritating me. Any student asking me doubts is not irritating me. It's in fact good. I feel happy if you guys ask doubts. Okay. So keep it up. I'm happy that you're asking doubts, and hopefully you find the right path, right track, and crack JEE very, very soon. All right. Okay. The current in a conductor is expressed as this. Current is in ampere, time is in second. Okay. Amount of charge. Isn't this concept repeated again? I mean the same thing. Remember, Q is equal to integral I dt from the limit 0 to t. It's the same thing. So it's 3t square plus 4t cube dt integration from 0 to what is that? No, not 0. The catch over here is this is not from 0. This will be from t1 to t2 now, because 1 and 2. So this is 1 second and this is 2 seconds. So just integrate this. T square's integration is t cube by 3. T cube by 3 plus t cube's integration is t raised to 4 by 4. And the limits are 1 to 2. 1 to 2. So put 2 first. 3 cancels, 4 cancels. So 2 cube minus 1 cube plus 2 raised to 4 minus 1 raised to 4. How much will it come out to be? Yes, check if the answer is 22. 8 minus 1, 7. This is 16 minus 1, 15. 15 plus 7, yes, 22. Yep, 22 is the answer. 22 what? Coulombs. Perfect. That is the correct answer. Awesome, awesome. Moving on to the next question on your screen. In the following circuit, the battery has some EMF, internal resistance. The power in the circuit is. Okay. I'll tell you, this circuit is not that difficult. If you notice, this 2 ohm and this 2 ohm, between this point versus these 2 points, actually these 2 points are at the same potential. This resistor is connected between this dot and cross. This resistor is connected between the dot and cross. The crosses are connected with a wire. That means they have same potential. So the voltage differences are the same. So they are in parallel. So the resistance will be 1 ohm. Same logic, I can use it for these 2 resistances here. So they are also in parallel, which means it will be 1 ohm. So strictly speaking, the equivalent circuit of this would be 2, and this, okay, I'll do one thing. There is this 1 ohm over here. Sorry, why did I say 1 ohm? 2 ohm over here on the top, and this one and this one, this one and this one are basically going to be in series, and then you have further 2 ohm over here, and you have this 2 volts over here, and this 2 by 3 ohms over here. 2, 2, 2. 2, 2, 2 in parallel will make it 2 by 3. Will make it basically 2 by 3. So essentially, I can write it down that this circuit further boils down to 2 by 3 ohms and one more 2 by 3 ohms connected to this particular battery of 2 volts. This is also 2 by 3 ohms. Furthermore, what you can do, both these resistors together will make it 4 by 3 ohms connected to this 2 volts battery. So hence, what is the current in such a circuit? Voltage by resistance. Resistance is 4 by 3. 2 cancels with 4. So it will become 3 by 2 amperes. So the current is now 3 by 2 amperes. But I think the question is, what is the power consumption of the entire circuit? Guys, I don't think I need even the current. Actually speaking, I don't even need the current. It was not necessary. My bad. I thought about something else. The power is asked. Power is nothing but V square by R. But this R will be R equivalent. Voltage is 2. R equivalent is 4 by 3. So V square by R. That's it. So 2 square is 4. 4 by 4, and that 3 goes on the top, cancels. So answer is 3 watts. Answer is 3 watts. Just check this out. Yes, the correct answer is 3 watts. Got it? Okay. So slowly you can see these two resistances are in parallel. Even these two are in parallel. So 2 and 2 will become 1 ohm. This will also become 1 ohm. They are connected one after the other between these 2 points. So 1 and 1 will become 2 ohms. This 2 and this 2 will become 2 by 3. But it is in series with this internal resistance. 2 by 3 plus 2 by 3 is 4 by 3. So equivalent resistance is 4 by 3. So voltage is known, equivalent is known. You can find the power now. That's the logic behind it. Right. Nice symmetry which is involved. Now look at this question also. I mean, this is also like, I'm pretty sure it will be oral only. You have to find what? Equivalent resistance. See, oops, sorry guys, I showed the answer. Yeah. See, in these kind of questions, no, some simple thing will be there. I can immediately see that this point is connected to this point via a wire. My bad. It is connected via wire. That means it is shorted. This resistance is useless, waste fellow. What is the use of this resistance? All the current will go via this bypass, via this pure wire. Wire is telling, I am not giving you any resistance. You come through me, flow through me. So this resistance is completely useless. So let me just draw duplicate. So before that, I am just saying we are shorting. Oops. We are just, where are we? We are basically shorting this. We are just shorting these 2 points together. So that means this resistance will become useless. So let me completely get rid of this resistance as such. It's of no use. It's of no use. Now this 2 ohms, what do you say? I think they are in parallel. Can you see 2 ohms and 2 ohms? If you notice very carefully, these 2 resistors are basically in parallel. If they are in parallel, get rid of them again, and I can replace it with one single resistance. I can replace it with one single resistance of how many ohms? Think about it. How many ohms the resistance will I replace it with? 2 and 2 in parallel means it will become how much? 1 ohm. So this will just become 1 ohm. So these 2 together will now become 1 ohm. Now can you see, my dear warriors? Now can you see, my dear warriors? This 2 and 1 basically are in series. How much? 3 ohm, because they are in series. And that 3 and this 3, they are in parallel. Can you see that? That 3 and this 3, basically they are in parallel. So what will it become? Actually, forget that. Well, there is one more resistor there. For now, just let's combine these 2. For now, let's just combine these 2. So let's just forget this. And just connect just a 3 ohm resistance. 333. All these 3 ohms are now in parallel. They are now in parallel. So the R equivalent will be 3 ohms divided by 3, which is basically 1 ohm. So hence answer should be 1. Yes, perfect. So the correct answer is 1 ohm. Is that clear how we have reduced the circuit? It was very straightforward. First started by shorting this resistance, then seeing these two in parallel, writing it as 1 ohm. This one is series with this 2 makes it 3. These 3 3s are in parallel, which will make it 1 ohm. Very nice question. I hope you loved it. I hope you loved it. There are chances of many silly mistakes in such questions. Aditya, I would suggest now, since you are in 12th standard, with the time remaining, I don't recommend studying many books. I would suggest to use teacher notes. A good teacher notes are self-sufficient for most of the theory. Yes, you will need to grasp few concepts here and there. For that, NCERT is mandatory. Okay. If you have time, use H.C. Verma. Otherwise, it's okay. I mean, with the time remaining, only do selective concept study from H.C. Verma. Otherwise, that is also not needed. Your good teacher notes, all right. Coaching modules. Sometimes coaching modules have very nice explanations, concepts, concept with solved example, or the definition and the example. All these things are beautifully written in a concise manner, in a short manner. So it's better if you can go through such coaching modules. Tatva module is one such module, which is the Vedantu coaching module. So if you want, you can go through that. So at this point of time, you do not have too much time for research, too much time to study new theory from different books. So class notes and DPPs and problem practice along with PYQs. That's the best strategy with the available time. Okay, and 80% of your time on 12th standard, 20% of your time in 11th standard. That's how you do side-by-side study. Okay, I hope I have answered your question. All right, let's move now to the next question. Two resistances are connected in series with a battery, negligible internal resistance. A voltmeter is used to measure the voltage across 100, which gives the reading as 1. Okay, I think it's better to draw this circuit diagram. Two resistances are connected in series. Okay, this is 100 ohm and this is 200 ohm, and it is connected across a battery of how much volts? 4 volts. Okay, perfect. And no internal resistance. A voltmeter is used to measure voltage across 100 ohm resistances. Voltmeter itself has some resistance. Oh, so why not treat the voltmeter also like a normal resistance? I don't know what the resistance is. I just assume it as R. Okay. And it is known that the voltmeter reading is 1 volt, means that the voltage across this is 1 volt, across this parallel combination. That means across this, it should be 3 volts. Isn't it obvious? If this is 4 totally, across this, if it is 1, the remaining will be 4 minus 1, which is 3 volts. Now, what I do for such questions is, think of this like an equivalent parallel resistance. Just combine these two into one single parallel resistance. And this is basically your 200 ohms. These two are basically in series. And the total voltage across them, is 4 volts. But across each one of them, it is 1 volt here and it is 3 volts over here. Because they are in series, what will be same? It is the current. Current is going to be the same. So this diagram I have converted into this diagram. So what is the value of current? Current is nothing but voltage divided by resistance, whatever is there. Total voltage divided by resistance. So use that concept for left side and right side. For left side, current is voltage by resistance. Voltage is 1, resistance is RP, and here voltage is basically, for the right hand side, voltage is basically 3 and resistance is basically 200. But what is RP, guys? parallel resistance, this into this upon this plus this. So it will be R into 100 upon R plus 100. This is equal to this thing, which is 3 divided by 200. A lot of stuff will definitely get cancelled. 0, 0, 0, 0. Okay, so I can just cross multiply. So R plus 100 is equal to 3 times of R. So take R on the other side. So 100 is equal to 3R minus R, which is 2 times of R. So R is basically 50. So 50 ohms should be the answer. Oh, I have done some mistake. Just check this out. Just check this out. Yes, I have done a mistake. While cross multiplying, I forgot to write it as 2R. So sorry. That was a mistake. Yeah, so these kind of silly mistakes do happen, guys. Be careful. So 2R and 2 into 100 is basically 200 is equal to 3 into R is basically 3 into R. Okay, perfect. Take this on the other side. So 200 will be 3R minus 2R, which is basically R. So R is 200 ohms. Perfect. This is the correct answer. Yep, there you go. I hope this is absolutely clear. Definitely, I move Virat. If you have 20% knowledge, at least 60% knowledge you can get in the remaining 5 months. With 60% to 70% knowledge, you can get 97 to 98 percentile easily. Understand that. It's not that 96% knowledge is equal to 96 percentage or 96 percentile. That is a wrong concept because weightage is different. Alright, number 1. Number 2, you don't have to do everything. You have to do selective things. Number 3, not everybody scores 100 marks. 100 percentile may not necessarily mean they solve 100 questions, all the questions. It might happen that toppers these days get everything correct. But just because somebody got 90 percentile does not mean he solved 9 out of 10 questions correct. It is much lesser than that. So get this in your head. So that's why even if you do 60 to 70%, that's a big deal and you will get 96, 97 percentile easily. So if you are at 20% knowledge, push yourself next 4-5 months. Okay, don't keep wasting more time. Next question. 2 cells are connected in the opposite directions, E1, E2, R1, R2 given. Find the voltage difference across this particular battery. Let's do this question. Okay. Yes, you can get NIT, everything, guys. You will get everything, but first concentrate on the class. All right. Okay, let's write down whatever is given in this particular question. 8 volts and internal resistance of how much? 2 ohms. This is 2 volts and internal resistance of how much? 4 ohms. 2 and 8. 8 is bigger. So I believe the current should go like this. This should be the ideal direction of current. So if you ask me how much current is going to flow, the net EMF by the net resistance. Net EMF won't be 8 plus 2, they are opposite, so it will be 8 minus 2. Resistance don't have any such problem. You just add the resistances. So it will be 6 by 6, which means it will be 1 ampere. So current is 1 ampere. Now, in order to find the voltage difference across this battery E2, lot of you might be thinking it is E minus IR. That is wrong. See, E minus IR works when the battery is discharging. If you notice carefully, this is the battery which is actually discharging because it is supplying current. This is discharging. So that means the voltage difference across these 2 points, will be E minus IR over here. But this battery, technically the current is entering inside it. So actually it is charging. So hence it is E plus IR. That's why it is a very good question. Many students made a mistake while solving this question, I remember. So E is nothing but 2, I is nothing but 1, R is nothing but 4. So it is actually 6 volts. Many people got the answer as negative 2. They thought I have to take a mod and they wrote the answer as 2 volts, which is entirely wrong. So the answer is 6. Understood? For charging it is plus, for discharging it is minus. How do I know whether it is discharging or charging? See the direction of the current. Current is coming out of the battery, it is supplying, so it is discharging. Current is entering inside the positive terminal, so it is getting charged. That's the logic behind it. No need of KVL also. Use directly E minus IR or E plus IR. Using KVL also you can get it. Manjunath, hi sir, I'm Ria. Sharon, your teaching is so good, I can understand easily your classes. Thank you so much. Glad, and make sure you are subscribed and liking the video so that all my next classes also you get. Number 2, all my old videos are lying down on the channel just for you guys. One shots, last minute revision, PYQs, zero to hero, pathfinder, nurture, roar. So much content is there. Using this content, you can be all India rank 1. But the point is you have to use. Okay, so it's all there on the channel. Make sure you are using it. All right. Moving on to the next question on your screen. In the given circuit, the current flowing through the resistance is 20 ohm, is 0.3. Okay, ammeter reading, that's here. It's 0.9. The value of R1. Wow. This value they are given, this value they are given, nothing about this. They have asked this. That's what JEE or NTA is for you. They give you this, they give you that, and they ask you that. Yeah. Cool. Let's do this. It's not that difficult. What do we do? I know that the current in this particular branch is 0.3 ampere. Current into resistance will give me the voltage. So what do I do with the voltage? Well, see, V is equal to IR. If I use that, current is 0.3 multiplied by 20. Point cancels, 0 cancels. So 6 volts. 6 volts is the voltage between these 2 points. Okay. I know this current. I know this current. How much is this current? 0.9. Okay. And I want to find the value of R1. If I know the current, I think my job will be done because I know the voltage. All of them are in parallel. Okay. So how about this? 6 volts will also be across 15 ohms. This will also have 6 volts of voltage because this and this are in parallel. So how much current will flow over here? How much current will flow through the 15 ohm resistance? Current is voltage by resistance. Resistance is basically 15. 6 goes with 3, 2 times. 15 goes with 3, 5 times. So it is basically 0.4 amperes. Wow. This is 0.3, this is 0.4. Using Kirchhoff's voltage law, Kirchhoff's current law, using Kirchhoff's current law, how much will be this current? Think about it. The total current is 0.9. From that subtract 0.3, also subtract 0.4. So basically what is left is 0.2 amperes. So this is 0.2 amperes. But I know the total voltage is still 6 volts. So use V is equal to IR. V is equal to I into R. So R is basically 6 divided by 0.2. Forget the decimal, 6 by 2 is 3. So because of the decimal, it will become 30. So the answer is 30 ohm. What a beautiful question. Involves Kirchhoff's laws, involves the concepts of parallel circuits, also involves Ohm's law at so many different places. So answer is 30 ohms. I hope you enjoyed this question. Yep. I hope this is clear. I hope this is absolutely clear. Very nice. Very nice. Moving on to the next question. Wow, we have completed current, electricity. Let's go on to capacitors now. Here are the capacitor questions. Capacitor ones are few in number, but they are tricky also at times, or sometimes even calculative. Okay, so be careful. Galvanometer of, where is it? 2 ohm, wow, is connected in the given circuit. The ratio of the charge stored in C1 and C2. Oh, interesting. We need to be little bit careful over here. I feel, let's do one thing. Let me first of all create a duplicate. Let me draw an equivalent circuit. Let us just even forget that this galvanometer is there because it doesn't look good for me. I will just redraw it as one single resistance. How does it matter? Of 2 ohm. Okay. Now, if you think carefully, you will realize capacitors always block the current. So just for the time being, let's just forget the capacitors because they are anyways going to block the current, just like this. And even this one over here. Yes, this one gets blocked. So this is how our current will go from here, from here, from here, from here, from here, and back to here. So how much will that current be? I think we can calculate that. That current will be the total voltage divided by the total resistance. So that current will be 6 volt by resistance, 4 plus 2 plus 6. 4 plus 2 plus 6, which is basically 12. 6 by 12 is 0.5 amperes. Okay, that's the current. Okay, now let's get back. Let's come back to this part. If I want to find the charge on this and charge on this, I need the voltage across this. In order to find the voltage between these 2 points, just think about it. What will be the voltage between these 2 points? The voltage between these 2 points, if I call it V1, it will be current into resistance. Current is 0.5. Resistance between these 2 points is 4 plus 2, which is basically 6. So 6 into 0.5 is 3 volts. So that's the voltage difference across this capacitor, which is basically how much? 6 volts. Sorry, not 6, my bad. 3 volts. It's basically 3 volts. Okay. In order to find the charge on this capacitor, I need the voltage drop between these 2 points. So how much will that be? Let's find that out. So the voltage drop between these 2 points, V2, will be again I into R. Current is still 0.5, but the resistance is this plus this, which is 2 plus 6, which is 8. 8 into 0.5 is 4 volts. So I got the voltage difference between these 2 points, which is now going to be 4 volts. Now comes the last part where you have to find the ratio of the charges. So Q1 by Q2, Q is CV, so C1 V1 by C2 V2. C1 is 4 micro, V1 is 3, divided by C2 is 6 micro, V2 is 4. 4 cancels, micro cancels, so 1 is to 2 should be the answer, which is option number D. Look at the number of calculations involved in this. First we got rid of the galvanometer, looked at it like a resistance. Next we thought these capacitors are pretty useless in terms of current because the current will only go through the resistors. Capacitors block the current. Fair enough. So I simplified the circuit to find the current in the circuit. Now then I thought, okay, to measure the charge on these capacitors, I need the voltages across them. To find the voltage between any of these 2 points, I went back to this diagram and I thought, okay, I know the current, I know the resistance in this path, 6 ohms and 8 ohms. So current into resistance gives me the voltage between these respective points. So multiplying the voltage with capacitance gives me the charge. What a brilliant question, isn't it? So even though it is an objective question, it is quite lengthy, which also means that you should be prepared for such, extent. It can be even lengthier than this. Nobody can say, why did NT or JEE put such a lengthy question? You cannot sue them or you cannot make a case in court. All right. 2 identical capacitors have same capacitance. One of them is charged, V, other 2V, negative connected together, positive is also connected together. The decrease in the energy is how much? Okay. These kind of questions have a standard technique. I will show you. See, this will repeat many times. This capacitance is connected across V volt. So the charge on this will be nothing but CV. There is another capacitor, identical I believe, yes, but it is connected across 2V volts. So the charge on that will be 2CV. C into 2V is 2CV. Okay. Now what you do is basically you are connecting the positive to positive, negative to negative. Okay. Positive to positive, negative to negative. Both these capacitors are in parallel. So why not look at it as one single capacitor? This is C, parallel capacitances will add, so it will become 2C, right? What about the charges? Charges, positive, negative, they will add. So the charges will also add. The new charge on this will be 3CV, CV plus 2CV. If you want it, I'll write it over here. CV plus 2CV, which is 3CV. It has to be conserved. Obviously, charges can't be destroyed. So now, find what is the energy stored in this. The final energy stored in this capacitance charge is known. half q square by c, half q is basically 3cv squared by capacitance, which is 2c. This is the final energy. Whereas if you talk about the initial energy in these capacitors, it will be half cv square plus half c into 2v square. So what is asked is basically the loss of energy or the decrease of energy. So delta U will be UF minus UI. Substitute everything, okay, everything is known and you will get the answer. Just check it out if it is 1/4 CV square. Solve this, you will get 1/4 CV square. Okay, just put UF and UI. UF you put it from here and UI you will obviously put it from here. Just substitute it over here. Got it? Got the logic of this problem? Yes. Awesome. Sir, motion of a straight line, what is needed? Then derivatives, integration of course, basic maths, alright. And you don't need units and dimensions, just simple visualization and just use my lecture, motion in 1D, you will understand everything, okay. Right? You don't even need the knowledge of vectors for motion in 1D as such. Even without vectors, you can do it. Somebody said, sir, I have many doubts. I want to ask you so many questions. Well, Lionel, you can do one thing. Send me a message on Telegram if you are on Telegram. Maybe we can connect there. And also you can put some comments below. We can definitely see through it. And maybe we should probably have Ask Me Anything session on YouTube. It's been a long time because so many lectures are being happening because I'm engrossed, completely involved in completing your syllabus. Yeah, I probably need to also spend time with you to see what is going on. I'll do that very soon. In an electrical circuit drawn below the amount of charge stored in the capacitor is, okay. Guys, whenever I see a capacitor, I know that it is going to block the current. I'm just going to forget it. Let's just forget that capacitor. What's the use? No use. This is going to completely block the current. Even that resistor will have no current passing through it. So nothing as such. So just forget about it like this. Okay, fair enough. Now what do we do next? Now I'll say that 4 ohm and 6 ohm are in series with the 10 volt. So the equivalent resistance, which is 4 plus 6, which is 10 ohm, they are in series. I can find the current in this particular circuit, which goes like this, right? So what is that value of the current? Current is voltage divided by resistance, so it is just 1 ampere. Okay. Now, in order to find the charge on this capacitor, listen to me carefully, very, very important. I will need the voltage across the capacitor, that is between these 2 points, Very interesting. In this branch, if I know the total voltage difference, maybe I can find this, but I don't know the voltage difference across R2. Look at it, between this point and this point, since the current is 0, actually speaking, there is 0 volts drop across it. I into R, 0 into R, 0. So there is no drop across it, which means whatever voltage drop is there between this point and this point is the same between this point and this point. This is same as this. Wow. So these two are same as voltage between these 2 points. So let me find the voltage difference between these 2 points now. Can I find out? Yes, because I know the current. Where is it? The current was 1 ampere. Current was 1 ampere. 1 ampere current was flowing. So the voltage difference is I into R. I is basically 1, R is basically 6. So it is 6 volts. So 6 volts is across this, which is also across this. But since this is 0, hence it is also across this. Hence, what do I get? Vc is 6 volts. Hence, the charge stored, which is C into V, capacitance is 10 micro, voltage is basically 6. So it is 60 micro coulomb. That is the charge. Let's find out whether it is correct or wrong. Yes, that's the answer. Such a brilliant question. Whenever you see a capacitor, forget it. That branch which has a resistor will have no voltage drop, no current. Just forget that and redraw it. You can figure out the branching and the currents using normal Ohm's law series parallel combination. Once you get that, use this logic. This drop is the same as this because this is 0, and this drop is same as this, which I can find out using Ohm's law. I hope you got it. Everyone understood? Loved this question? Can we go ahead to the next one on your screen? Okay, let's go. Here it is. In this particular circuit which is drawn, the amount of charge which is stored in the capacitor is, okay, oh sorry, this is done already, my bad. A parallel plate capacitor with separation of 5 is charged by a battery. Okay, it is found that on introducing some sheet, while keeping the battery connections intact, the capacitor draws more charge from the battery. That constant is, okay, let's draw the two situations so that I am very clear. So this is the capacitor, this is that particular battery. The old capacitance would have been epsilon naught A by D and charge being C into V. So it will be epsilon naught A by D into V. That is the charge. Old one, when there is complete air gap between. Now you introduce a dielectric but of a small thickness in between that particular plates. So the dielectric is only there in some part of it, no issues, but the battery is still the same. Capacitance will change. So the new capacitance is epsilon naught A by D by K, D by K summation. This thickness is, okay, earlier this D was how much? If you notice, this D was basically 5. So this was basically 5 millimeters. Let's keep everything in millimeters for now. There is no harm in doing that. I feel everything will be in terms of some ratio. Okay. Here what I will get is D is how much? 2 by K I don't know, plus the remaining is 3 millimeters by K is 1. This is for the dielectric, this is for the air gap. This is for that particular air gap. That's the formula modified for partially filled dielectric inside a capacitor. It's epsilon naught A by D for complete air, but if there is something, it is D by K, D1 by K1 plus D2 by K2, D3 by K3 summation. As many slabs as you fill, that many terms will come. Air gap is also like a slab. You can think it's a slab of dielectric constant 1. That's it. Now the new charge which is C into V will be nothing but epsilon naught A into voltage divided by 2 by K plus 3 by 1, which is again 3 only. It is clearly mentioned the capacitor draws 25% more charge, which means Q new, because it is 25% more. So 25% more means 0.25. You have to add to the old charge, 0.25 Q, you have to add to the old charge. So the new charge will be 1.525 times. So the new charge will be 1.25 times our old charge. 0.25 has been added. So 1 plus 0.25 is 1.25. This you already know is nothing but epsilon naught AV by 5. And the remaining stuff over here, epsilon naught AV divided by 2 by K plus 3 is equal to 1.25 is 5 by 4. A lot of stuff will get cancelled like epsilon, A, V, 5. Solve this, bring it on the top and you will get the answer. Okay. Bring everything in the numerator. So 2 by K plus 3 is equal to 4, I believe. Yes. Take it on the other side. 2 by K is equal to 1. So therefore, K is equal to 2. That should be the dielectric constant, which is an answer. Yes. Yeah, there you go. Yeah, it's just time consuming, of course. And you cannot blame anybody for that. You cannot say, sir, time is being consumed, so I will not do. So we'll find 5-6 questions like that. What will you do? You cannot afford to lose marks, na? So don't get bothered by time consuming questions. Remember, for advanced though, it is even more time consuming. So we have to be as fast as possible. Capacitor C, voltage V, energy E, connected to another capacitance 2C, voltage 2V. Don't you see, same model of question just got repeated, just that the values are different. Just that the values are different, nothing else. So redraw these scenarios. Capacitance C, voltage V, okay. Capacitance 2C, voltage 2V, perfect. The original charge on this one will be CV. The original charge on this capacitor will be 2C into 2V, which is 4CV. The original energy, initial energy, will be E, which will be given by half CV square plus half 2C into 2V square. Now you connect these capacitors. I think it is connected to the other capacitor. So what will happen? What will happen is basically something like this. These both will be in parallel, so I can just look at them as single capacitor. C plus 2C is basically 3C. Total charge will be CV plus 4CV, which is nothing but 5CV charge. 5CV charge, which will be conserved. Obviously, charge can't go anywhere. So the final energy will be half charge square, which is 5CV square, by capacitance, which is 3C. Now the question asked is about the loss again. So delta U is the loss of the energy. So delta U will be nothing but final minus initial. Substitute the answer, you will get the answer. Thing over here. So put final over here and put initial over here. Put initial over here. Final and initial. That's it. You will get the answer. The answer comes out to be 2. That means it is 2 by 3 times of E, whatever this is. If you assume it as E, it is 2/3 of E. That's it. Okay. Again, just calculative, time consuming, concept repeated again and again. The same concept, I just showed it to you some time back. Next one. In the given figure, the charge stored is 6 micro. When points A and B are joined by the wire, then what do you think will happen? Okay, let me redraw. Let me create a duplicate. I'm just connecting these points A and B. Wow. Capacitor, I don't like. What does the capacitor do? It blocks the current. So next step, I'll just forget the capacitor. Capacitor is just going to block the current completely. So just forget as if there was a capacitor at all. Wow, now this looks like a simple circuit. The current will go from here, go like this, go like this, go like this, go like this. Very, very easy. Current will be voltage, which is 9 minus 0. This is 9, this is 0 volts, remember. Upon R. R is basically 6 plus 3, which means it is 1 ampere. Okay, fair enough. I know the current now. What is the question? The question is, the charge on this capacitor. Which capacitor? This capacitor. If I want to find the charge on this capacitor, which means I need to know the voltage between this point and this point, which is technically the same voltage across this resistor. Whatever voltage is here is the same voltage across this, because this point is the same as this. This point is the same as this. Same voltages, same difference, same difference. How do I find the voltage across 6? I know the current is 1 ampere. So this voltage, which is I into R, will become 1 into 6. So voltage is 6 volts. So hence the charge, which is capacitance into voltage, 6 micro into voltage, which is 6, it will be 36 micro coulomb. Hence the answer should be 36. Yes, it is 36. 36 microcoulomb. Thank you, Lionel. Thank you so much. Thank you so much. I'm so glad you consider me that way. And let's go to the next one. This is done. Yes. Here is the next question. Just try to think about it. Worst part, diagram is not given. Second worst part, it's an integer type. That means no options to eliminate. So what's the only option? Start with the diagram. Be confident in your solution. That's it. Okay. So if you take a square loop, like this, and across the diagonals, and 1 ohm across its sides, a 9 volt battery with some internal resistance. Okay. Like this, I believe. Okay. So there is this battery over here of how much volts? 9 volt. 9 volt, 1 ohm. Okay. And 16 ohm wire is made into a square. That means each side will be 4 ohm each. Each side will be 4 ohms each. That is the meaning of this. Okay, this is one thing. Now, what you have done is you have connected a capacitor also, where across the diagonals, across one of its diagonals, doesn't matter which diagonal. So, oops, let's say this is this capacitor which is connected across this point. How much? 4 microfarad. Everything is like 4, 4, 4, 4. Okay, very nice. So the question is, what is the energy stored across the capacitor? In order to do that, remember, capacitor always will block the current. So just forget the capacitor for a moment. Just look at this diagram. This looks like, simple series and parallel combination circuit. So, what should happen is these 3 resistors are basically in series. Hence, this should be 4 plus 4 plus 4, which is 12 ohms. That is in parallel with this 4. So, RP, which is 12 into 4 by 12 plus 4, which is 48 by 16, which is basically 3 ohms. So, that's the parallel resistance. That parallel resistance is in series with this, right? Is in series with this 1 ohm. So, remember that 3 ohms is in series with this 1 ohm, which is connected to this particular battery of 9 volts. So, the current which will be flowing in this particular circuit will be voltage by resistance, which is 3 plus 1 ohms, which is 9 by 4, which is basically 9 by 4, what is it? Amperes. Is that fine till this point? Everyone? Current is 9 by 4 amperes. But that's not the end story. That's not the end story. Once I find the current, I need to think back. I have to find the voltage between these 2 points. That means somehow I need to know how much current goes through this branch. How much current will go through that branch. So I'll go back over here. Where is it? Yeah. So if this 9 by 4 amperes goes here, this will get distributed somewhat here and somewhat here. Some current will go here and the remaining current will only go over here. Remember, the currents get divided in the inverse ratio of the resistances. So if I call this current as I1 and if I call this particular current as I2, then I can just say I1 by I2, because it is going to be inversely related. This current will be inversely related to 4 ohms. This I2 will be inversely related to this 12 ohms. So which is going to make it nothing but 3 by 1. that is I1 by I2. But if I use componendo, I1 plus I2 divided by I2 will be 3 plus 1 divided by 1, which is 4 by 1. I1 plus I2 by Kirchhoff's current law, I1 plus I2 will be 9 by 4. So this is basically 9 by 4 divided by I2. Therefore, I2 will be 9 by 4 into 4, which is 9 by 16 amperes. So I found the current in this particular branch. Okay. Now what do I do next? I come back here and I look that, okay, listen, I want to find the energy. That means I also need to know the voltage between these 2 points. If I want to find the voltage between these 2 points, the only way is I multiply the current which is there in this particular branch, which is I2, into the resistance. Current I2, we just figured it out, it was 9 by 16. Resistance in this branch is 4 plus 4, which is 8 ohms. 8 by 16 is 2, so 9 by 2, which is, yeah, just keep it like that, it's okay. 9 by 2 volts. 9 by 2 volts. Now the question is, what is the energy stored? Okay, so the energy stored is half CV square. Capacitance is 4 micro. Voltage is 9 by 2, but you have to square it. 2 square is 4, 4 cancels, so 1 by 2 into micro into 9 square is basically 81. So I'll just get 81, which is basically 4, or just keep it like that, 81 by 2 microjoules. So 81 by 2 microjoules, answer is 81, yes, perfect, we got it. So again a lengthy question, you had to first of all, visualize what the question was by drawing it. This diagram was not given. Capacitor was there, but I thought let's keep capacitor aside because anyways it is blocking the current. These were in series, their combination was in parallel, and these together was in series with 1 ohm. So my first step was to find out the equivalent and how much net current was flowing in the circuit. But this net current will get distributed in 2 branches. This branch and this branch are in parallel, and whenever currents are in parallel, they are inversely related to the resistance. So I1 is to 4, I2 is to 12. I1 is inversely related to 4, I2 is inversely related to the 12 ohms. And then I thought, why not do componendo? Because if I add these currents, I will get the total current by Kirchhoff's current law. So I did componendo property over here in case some of you did not realize it. I've just used componendo. And this was nothing but current is inversely proportional to resistance in parallel circuits. Solving this, I found the current in this branch. Once I get the current in this branch, finding voltage between any 2 points is just a simple thing. You just do I into R. But that R will be from this point to this point, which is 4 plus 4, which is 8 ohms. Right? As simple as that. Lovely question, guys. I hope you enjoyed this. Moving on to the next one. The charge on this particular capacitor. Again, they love finding the charges, energies, voltages across capacitors, especially a combination of resistor and capacitor problems. How do I do that? I need the voltage between the points A and B. I will need the voltage between this point and this point. So maybe for now, let's just forget that there is a capacitor and let's solve the problem. It's just because capacitor anyways does not affect the current flowing in the circuit, it blocks the current. And what I can see initially is this 1 and 2 ohms together is in series. Oops. This 1 and 2 ohms together is in series over here. So it is basically 3 ohms, and 3 ohms has 10 volts. So the current which will flow in this particular part of the circuit is voltage by resistance, so 10 by 3 amperes. If you look at this particular branch of the circuit, that is also in series 6 and 4. So that is 10 ohms. 10 ohms across 10 volts. So that would be 10 divided by 10, which is 1 ampere current, which is going like this. Now I'll go back to my original circuit and I will show those currents. So this was 1 ampere, which was going like this. And over here, that was 10 by 3 10 by 3 amperes, 10 by 3 amperes, which was going like this. And what do I need to find? I need to find the voltage difference between this point and this point so that we can find the charge. So how about this? I apply Kirchhoff's voltage law from here to here. I apply Kirchhoff's voltage law, but not complete loop law, partial law. Okay. So starting off with potential at point A, since I'm going against the current, the voltage will be increasing by plus IR. So current is 10 by 3, resistance is 1. Starting from here, going like this, against the current, it is always increase because current goes from high to low. So I am going from low to high, that means there is an increase. From here to here, in the direction of the current, it will always drop. So it will be a dropping by current into resistance. Finally, I end up reaching here. So the voltage at that point is VB. Okay. Now, what I can do this VA minus VB is take that 6 on the other side, take that 10 by 3 over here. So this will be the voltage difference between A and B. 6 3s are 18 minus 10 divided by 3, which is basically 8 by 3 volts. That is the voltage. But that's not the question. The question is the charge. So charge is C into voltage between A and B. Capacitance, how much is the capacitance? 150. 150 microfarad into the voltage, which is 8 divided by 3 volts. 3 goes with 150, 50 times, 8 5s are 40. So 400 microcoulomb. 400 microcoulomb should be the answer. Yes, that's the correct one. So again, you can see we are forgetting the capacitor which was originally given in the question. Finding the distribution of the currents, and wherever required Ohm's law, Kirchhoff's laws, we are applying that to find the voltages across the capacitor and then finding the charge or the energy. Yep, that's the correct one. Very good, Harborine. Hello, Golubili Lokesh. Hello, sir. Take my name, Nathik Thakur. Hello, Bacha. Hello, my dear student. That was a brilliant question. And moving on to the next one. Wow, we have completed all the PYQs January today and before this April attempt. So all the PYQs. I think there were a couple of 100 questions together. That's immense practice of this topic. And if you attended these 2 classes, trust me, you are at the next level now, especially from current, electricity and capacitors. Now, you cannot stop there. Obviously, you cannot be happy, oh sir, I'm done. Obviously, you need to practice more. Use the old PYQs of 22 and 23 in hard copy format with solutions. None of the questions are missed. All the questions are segregated subtopic wise as well as shift wise and with proper solutions, not just the answer key. In the hard copy for all the 3 subjects, the link is there in the description box below. All the 3 books, my dear students. You can see the link is there right over here as you're watching this video. Just go down over here and you can see JEE PYQ books. That link, click on it. It is also pinned in the chat box. Right now it's on sale for 899 rupees. It includes everything, no additional cost for shipping, etc. Okay, so it has total of 1380 questions, guys, from all the subjects, 46 papers for all of you. I mean, that is immense practice. Add it to your cart or say buy it now and use this link to buy it right now. You can see it's just, and you are getting it at an additional discount because you are using this coupon code VT10SH for just 800 rupees, guys. I mean, 800 rupees is like a large pizza. So instead of a large pizza from some shop, you are ordering these books which has a collection of 46 shifts JEE Mains previous year papers. Solve this and make sure you are liking the video. And oops, not ray optics, guys. Oops. Yeah. Current, electricity and capacitors 2024 PYQs done. So just mention that in the comments. I would be very happy to see that comment and see you very, very soon. Okay. Have a great time. Have a lovely evening. Have a great dinner. Take care. Keep smashing the like button. Keep spreading the love and stay subscribed on the Vedantu JEE English channel. Bye bye. Captain Shreyas signing off. Hasta la vista.